We are here again. Welcome to Chem Classroom with Auntie Taiwo. So today we'll be moving to another question under chemical equilibrium. We have been able to define chemical equilibrium. We stated the factors affecting chemical equilibrium, and we even mentioned the principle, which is Le Chatelier's principle. And the last video, we were able to solve a question relating to exothermic reaction, a standard question. So today we'll be solving another question under chemical equilibrium, that is endothermic reaction. So please, let's go to the board and see what we have. Consider the reaction at equilibrium. This equation was given, and our enthalpy, our delta H, is given as what? Plus 95 kJ per mole. So what this means is that this reaction is what? Endothermic. I emphasize that nobody will tell you if the reaction is endothermic or exothermic, but with the delta H, if it's positive or negative, you will be able to know if it's endothermic or exothermic. Okay, now let's move to the board. Consider the reaction, right? The equilibrium constants. So the first one, the equilibrium constant, I'm going to take the product, which is a PlC3, then the chlorine gas divided by, please always use your square bracket, please. So we are done with the first question. So the second one says increase in temperature, in pressure. What's going to happen with increase in pressure? I will have to rewrite the equation for us to be more specific. So here, the increase in pressure here, I have 1 here, 1, 1 as coefficient. So for the reactant side, I have 1. For the product side, I have 2. So if there is going to be increase in temperature, it's going to be increase in pressure, rather, is going to be to the reactant side. So here now, the backward reaction will be favored. The backward reaction will be favored. So what this means is that the equilibrium will shift to the left. Yes. So the second one here is what? Increase in temperature. Now, I said it that this reaction is endothermic, and there is a standing rule. So increase in temperature would definitely favor the forward reaction. So increase in temperature, the forward reaction will be favored. So equilibrium will shift to the right. Okay, so now the third one says removal of chlorine. Removal of chlorine. When chlorine is being removed, more of the reactant will react together to produce more of the product. So more reactants will collide together to react to form more of the product. Okay, that is what I have. So the last one, sketch and energy provide diagram. We don't have the space on the board, but I will explain what you're expected to do. So what you're expected to do is just to draw the diagram for what? An endothermic reaction. And in an endothermic reaction, you show the activation complex, the activation energy, the product side and the reactant side. But there's a difference between endothermic reaction and exothermic reaction in the diagram. For endothermic reaction, the product is higher than the reactant, while in exothermic, the reactant is higher than the product in the diagram. So you can easily find any chemistry textbook and see the difference between the two diagrams. Okay, when next we meet, we'll be going to other aspects of chemistry. So please click on the subscription button and the notification bell so that whenever we upload our videos, you get to see them on time. Thank you for staying on the channel. All right, see you some other time.